Okay, we can start. We are doing tutorial 8 today, and it's on structural design of flexible pavement, and we started it last week. I hope you have done the last week, finding the modulus of asphalt and finding the modulus of granular layer. So today we will discuss about the design traffic, and next week you have um, questions on finding allowable traffic. So what are these two things? Allowable traffic and design traffic. You need this for your practical as well. So design traffic, we use this NDT. N for the number, DT for design traffic. For allowable traffic, we use the letter N, just the letter. So what is the difference between these two? Yeah, allowable traffic is what is the pavement allowing us to put on. Design traffic is what we need to put on the pavement. So design traffic is what is our expected traffic. And allowable traffic is what is allowed by the pavement. So when pavement design, we start with a trial pavement. So we need to know, we have to decide which trial pavement we want to go ahead with. That means we select our materials, maybe asphalt, 2 asphalt layers, and also cemented layer, or maybe a granular layer and the subgrade. So likewise, we start with a trial pavement, and we give our own thicknesses for the trial pavement, and we are finding out when we put this design traffic whether these pavement layers can be okay or not. So we are going to find out the allowable traffic for these different pavement layers. So do you know where the critical points in this flexible pavement? Before that, which one, if you compare the NDT with the N, or the design traffic with the allowable traffic, which one need to be higher? Which one? Allowable need to be higher, isn't it? Design traffic is our expected traffic. Pavement should allow more than the design traffic. So this should be more. Am I right? And your practical, we define another parameter called CDF. CDF is NDT divided by N. So if you look at the cumulative growth factor, CDF, it should be less than 1. Am I right? Because to satisfy this condition, the CDF need to be less than 1. Agree? All good? Okay, so now to compare these two, compare design traffic and allowable traffic, both need to be in the same units, isn't it? You can't compare 12 feet with 2 meters as keeping it like that. You need to convert feet to meters or meters to feet to compare it. So we need to know how to convert from different unit to another unit, because NDT we calculate by a unit called heavy vehicle axle groups. But this N, the allowable traffic, will not be in heavy vehicle axle groups. When we calculate it, we get a different unit for that. So we are first going to learn how to find this unit, how to do this unit conversion. Okay, so that will be our first question. Do you guys have any question up to here? No. Okay, so when we consider these things are important, otherwise you don't understand the question. When we consider the structural design part, we only consider the heavy vehicles. We are not considering the light vehicles. These are the light vehicles that we have. They are not damaging the pavement. Pavement get damaged by these heavy vehicles. So light vehicles are important for geometric design part, because we need to know the volume to find out how many lanes we need, whether it should be a roundabout or whether it should be a traffic light junction. So to find all that for geometric part, yes, we need to know the total volume of the vehicles. But for structural design part, we only consider the heavy vehicles, because heavy vehicles are they are the only thing that will damage the pavement. Are we good? Okay, so when you consider the heavy vehicles, it's not just the number of heavy vehicles. We need to know how the tire configurations, how many axles we have, and in axle, how many tires we have, and how much of load is applied. So if you look at this picture here we have 4 axles. Do you see that? And it has 2, maybe we can't see how many number of tires we have, but that number of tires also important. Here we have two axles. Two axles can be with single tires, or two axles can be with dual tires in each axle, like this. We don't see that one from this side, but when you walk on the road now, you can have a look. There are different types of axles and different tire configurations. So these ones, SAST, SADT, stand for this number of axles and the number of tires. SAST means single axle, single tire. So single axle, dual tire is SADT. So likewise, these first two letters are for the number of axles, second two letters are for the number of tires in the axle. Are we good? Any question? No question? Yes. Tandem means two. Yes. Tri means three. Yes, tandem means two. Okay, now the next thing. Next part that you need to know is the critical points in the flexible pavement. When in a flexible pavement, the load is applied underneath the tires. I hope you know that part. And if you consider the asphalt layer here, at the top of the asphalt layer, it is compression, undergoing compression. At the bottom of the asphalt layer, it is undergoing tension. So the critical point is this point here. So at the bottom of the asphalt layer, due to tension, it can break. And also when you consider the cemented layer, again underneath the cemented layer, due to the tension, it can break. Subgrade at the top is the critical point. So at the top of the subgrade, due to the compression, it will break. So we have a critical point in the asphalt layer, and also critical point in the cemented layer, and also in the subgrade. So these are the three critical points that we have in the flexible pavement. Does that make sense? Okay. Now, we can find allowable traffic for these three critical points using these equations. So N, I told you, N stand for the allowable traffic. So allowable traffic for asphalt, you can find from this equation. RF is the reliability factor. This is the modulus, asphalt modulus. You learned last week how to find the modulus of asphalt. And this is the microstrain. Microstrain should be given to you. We can find it from the circling. And this is the percentage of binder, bitumen. And if you know all that, you just put the numbers and you can find the allowable traffic for asphalt. And your answer will be in SAR 5. SAR 5 means standard axle repetition 5. So that is another unit. So we have so far discussed about the heavy vehicle axle groups. Did I say you that? No? NDT, when you find the NDT, you get it in heavy vehicle axle groups. It is a unit to measure the vehicles, the traffic load. And this is another unit that we can use to measure the traffic. This is another unit, this is another unit. When you put the numbers in this equation, it gives you the traffic, but in different units, like meters, centimeters, millimeters, feet. They give you the same thing, the length, or else this one, the traffic in different units. If that makes sense? Okay. So, and also we said that NDT should be less than N. So when we compare these values, can we keep these different units and compare? For example, for asphalt, when you find N is in SAR 5. But NDT, when you calculate it, you get it in a different unit called heavy vehicle axle groups. By keeping these two units, can we compare them? No, we need to make it to a single unit. So we need to know how to convert units from one to another. So that's what we have in the first question. So this is our first question. You only have this part, I think, in the tutorial, but the rest is not that hard anyway. We have 2 years ago, we had everything together. Okay, so in this question, they say the traffic projection for a new pavement of a 2-lane urban dual carriage is as follows. Design period is 30 years. Annual average daily traffic is 5,500 vehicles per day. Direction factor is 0.5. Direction factor means in a road, you can have one-way roads or both the ways, two ways. So in that case, it will be 50-50. So that is 0.5, 0.5. Direction factor is 0.5. Percentage heavy vehicles, 10%. So out of this 5,500, only 10% is heavy vehicle. That's what we need. We are not going to look at all the vehicles. We are looking at only the heavy vehicles. And the average traffic growth is 3%. So we are designing for 30 years. We can't say this 5,500 will remain the same. It has a growth of 3%. Average number of axles per heavy vehicle is 2.5. And they are asking us to find the NDT. Do you understand the question? So all this given to us and they are asking us to find the NDT. To find the NDT, we have an equation. So that equation is this. So you can put the numbers in this equation and find it. So let's see what are they. So annual average daily traffic, AADT means average annual daily traffic. To make it to years, for the whole year, you need to make times by 365, am I right? And direction factor, DF is the direction factor, percentage heavy vehicles, and lane distribution factor, LDF, cumulative growth factor is CGF, and NHVAG is the average number of axle groups per heavy vehicle. Okay, so when you have what are the things we know from the question? Which ones we know? Yes, we know AADT, which is 5,500. Am I right? Direction factor, do we know that? 0.5. Percentage heavy vehicles, 10%. A lane distribution factor, we don't know. We are going to find it. Cumulative growth factor also, they haven't given us, but we know 30 years, 3% growth. With that, we can find it. Average number of axles per heavy vehicle, it was given as 2.5. Am I right? So these are given. So two things, we need to find two things, lane distribution factor and the cumulative growth factor. So lane distribution factor, we can find out by two ways. One is we can collect our own data. So you may have seen that black strips on the road to find the data from the vehicles. Have you seen that when driving on the road? Yes. So they we call the weighing motion data. So we can collect data and find out. Otherwise, we use the Off-road guide. So in the Off-road, if we don't have weighing motion data, we use this table 7.3 and we find depending on whether we are designing for a rural road or an urban road. In our case, what kind of a road we are designing, rural or urban? Urban, yes. And how many lanes? 2 lanes. And we are designing for the mostly heavily trafficked lane. So that means the left lane, or most of the vehicles are going in the left lane when they overtake heavy vehicles. Overtaking, they are taking the right lane. So we have to take lane distribution factor as 1. But if you have, in case if you have 3 lanes, the maximum is this one, 0.65. The lane distribution factor will be 0.65. Lane distribution factor is how much is how the vehicles are distributed among the lanes when we have many number of lanes for the same direction. Does that make sense? Any question? Okay, so lane distribution factor will be 1. And cumulative growth factor you can find from this equation. This is again from Off-road. So if your R is 0, that means the rate of annual growth is 0. Your lane cumulative growth factor will be the number of years. But in our case, this one is 3 and 3%, am I right? And this is 30 years. So you can put these numbers in the equation and find this one. So can you find me cumulative growth factor, please? I gave you some workboard. What we get? You just put 3, okay? Not the percentage. R is 3 in your case. 3. 33. So 1 plus 0.01 times 3 minus 1 divided by 0.01 times 3. What do we get? Oh, sorry, 30 to the power. 47.6. Do we get this? 47.6? Okay. So we know everything now. So when we put everything in the equation, what do we get? So can you put everything in the equation and find me NDT? It's a big number. You need to make it to 10 to the power something, okay? 1.19 times 10 to the 6, 7. Is that right? Is that what you get? Do you get the same? So this is in heavy vehicle axle groups. The units are heavy vehicle axle groups. So this many number of heavy vehicle axle groups are there. Does that make sense? Okay. Any question? Okay. So that's the first part of the question. Now we need to convert it to different units. So this is in heavy vehicle axle groups. And they have given you this ratio. This ratio is 0.7. So how can we convert the heavy vehicle axle groups to ESA? So ESA over HVAG is given to you, 0.7. If you times by 0.7, what will happen? Then distribution factor was 1. So this heavy vehicle axle group unit will cancel out and you get the answer, which is 1.19 times 10 to the 7 times 0.7 in ESA. ESA stand for what? ESA stand for what? Equal standard axles. Now you guys have to familiarize with these terms. ESA is the standard axle, equal standard axles. So what do we get? Okay. Now we have time. So can you quickly convert these to these ones as well, please? So this is right. Whatever you got is right, yes. SAR 5. That will be this, am I right? So if you just multiply by that ratio, so you can find them. Now, if I ask you, are they the same or they are different? Are they the same or different? This is their design traffic. So are they different things, five different things, or are they the same? They are the same, but different units. For example, if I ask you 100 centimeters and 1 meter, they both gives you the same length, but they are in different units. Similarly, this gives us the design traffic in different units. Why we need to know it in different units? I told you at the very beginning why we need to know how to convert them into different units. And the N, yes. N, if when you find the allowable traffic will be found for different layers in different units. So we should be able to compare the NDT with the allowable traffic. So we need to know how to convert it. In case if you need to, if I ask you, if you know, you don't know this, but if you know SAR 5, this one is 10 to the 8. If I ask you to convert this to heavy vehicle axle groups, how do you convert this to heavy vehicle axle groups? You divide this by 0.9. Am I right? So your answer will be in heavy vehicle axle group. So you need to figure out whether you need to multiply or divide. And also, if I ask you to convert this to ESA, how do you convert it to ESA? You need to first find it in HVAG and then convert it to ESA. Am I right? And the other thing is these ratios are not the same for all the projects. It depends on the traffic. Anywhere on earth, if you consider, 1 centimeter, 100 centimeter and 1 meter, they are equal everywhere on earth. 100 centimeters is equals to 1 meter. But these values here, the conversion factors will be different to different projects. So we should know how to find this one as well. In the next question, we are going to find out this one, how to find these fractions. Any question? We finished with the first question. Do you guys have any question regarding the first part? No? Oh, good. Okay, next question is this. The traffic load distribution for a lane is shown in table 1 below. Calculate the average number of axles per heavy vehicle. So this need to be found here. In the previous question, this was given to you. Do you remember? This was given to you as 2.5. When you consider a heavy vehicle, it has averagely 2.5 axles. It was given in the previous one, but here they are asking us to find it. And determine the average. Here you have, I think, ESA over heavy vehicle axle group for the, that one here. Okay, so do you understand this table? ESA, you are finding for ESA. You have to find for ESA. I'll explain you for finding anything. Okay. So you can, if you want, you can find for all four. Do you understand this table? What's that? Oh, that's okay. Yeah. You have to do some questions, then only you will get familiarized with the terms. Do you guys understand the table? I mean these numbers, what they mean. So this will give you the proportion of each axle group. So if you consider 100 heavy vehicles, 30 out of the 100, 32.1 is single axle, single tire. 12.4 is single axle, dual tires. And 1.1 is tandem axle, single tire. 35.1 is tandem axle, dual tires. And 19.3 is tri-axle, dual tires. And when you add all these together, you get 100. Am I right? Instead of giving these percentages, they have given you proportions. So that's the only difference here. When you add all these together, you don't get 100. Instead, you get 1. Am I right? So that is the proportion. And what are the numbers at the top then? So this SAST is all the single axle, single tires are not with the same weight. Some are 40 kilonewtons, some are 50, some are 60. So they are saying out of this 32.1%, 12% is 40 kilonewtons. Does that make sense? 41% is 50 kilonewtons and 47% is 60 kilonewtons. Does that make sense? So that's how we read the table. Do you guys now understand the table? Any question? Yes. That's the weight coming from that axle. Maybe the heavy vehicle has 100 kilonewtons, but that particular SAST is only applying a 40 kilonewton load on the road. Got it? Okay. Now, yes.
Can you do that again?
What's that?
0.12% of 40 kilonewtons or what?
Okay, so when you consider all the heavy vehicles, 32.1% is SAST. Out of the 32.1%, 12% has 40 newtons, 41% is 50 kilonewtons, 47% is 60 kilonewtons. Make sense? Okay, now in the first one, they are asking us to find the average number of axle groups per heavy vehicle. Average number of axle groups per heavy vehicles. If you know total number of axles, and if you divide by the total number of heavy vehicles, can't we find the per heavy vehicle, how many axles are there? If you divide the total number of axles by the number of vehicles, we get per vehicle how many axles are there. Am I right? So do we know the total number of axles? Do we know the total number of axles? What it is? This will be your total number, isn't it? It can be 1, or if you want to make it to a percentage, you can say 100. Am I right? How do we know the total number of heavy vehicles? In the question you don't have, but can you find it from the table? How did you find that? You can find it if you know the number of steering wheels. Can you find the number of vehicles? It's equal to the number of steering wheels. Am I right? All the single tire axles are connected to the steering wheel. If you count the number of single tire axles, that will give you the number of steering wheels, which is the number of heavy vehicles. So if you add these two together, that will give you the number of axles which are connected to the steering wheel. So we can say 0.321 plus 0.011, or else if you want to make it to a percentage, 32.1 plus 1.1. So when you put this in the calculator, you get the number of axles per heavy vehicle, average number of axles per heavy vehicle. Now you can, when you walk on the road, you can have a look. Always you see the front axle is with single tires. It can be one axle in most of the cases. Rarely you will see two axles at the front with single tires connected to the steering wheel. This is very rare, but you can find them. But these are the mostly available heavy vehicles. What do we get? What's that? Yes. So 3.01, do we all get that? Any question up to here? No questions? Can I move on to the next part of the question? Okay, so. Okay, now let's say this table, we already understood how to read the table. So if I ask you how many percentage of SAST we have with 40 kilonewtons, how do we find this one? If I ask you percentage of SAST with 40 kilonewtons. SAST is what? 32.1%. Out of the heavy vehicles, only 32.1% is SAST. Am I right? Out of this, yes, out of this, 40 is 12%. Isn't it? Is that right? So if I multiply these two, I get the percentage of SAST 40 kilonewtons. That means if I times 0.321 by 0.12, then I get the out of the total heavy vehicles, how much of proportion is SASD 40 kilonewtons. Am I right? And then for 50, 0.321 we times by 0.41. Am I right? In 321, I times by 0.47. Now, if you see this, when you add all these together, it is 1 again. See? And when you add these together, again 1. So this is the percentage of different axles and tires, and this is the load in percentages. So we need to times both to find out of the heavy vehicles, total heavy vehicles, how much proportion is different loadings. Does that make sense? Can you find this for me? So we need to fill the whole table actually. You guys are lucky. In my time, we didn't have camera phones. Do we get this? Okay, if you have done this right, when I add all the numbers together, what should I get? 1. Any question up to here? No questions? So we'll keep this table aside and we are going to now find out the damage created by these loads. Okay, so to find the damage, we use the standard axle. So what do we mean by the standard axle? Standard axle is a single axle with dual tires with 80 kilonewtons. So we consider the damage created by 80 kilonewton single axle dual tire is just 1. Damage is 1. So if, we have SADT, but we don't have 80 kilonewtons. Am I right? So if we look at our table here, we have SADT, but we don't have 80 kilonewtons. We have instead of 40. If the damage created by 80 kilonewton is 1, how much of damage created by 40 kilonewtons? Just half of it, isn't it? So that will be 40 divided by 80, isn't it? So if for 50 is creating how much of damage? 50 divided by 80. Am I right? Next one will be 60 divided by 80. So this is for the standard, single axle dual tires. But if you look at the SAST, the damage, which is 1, damage created by how many kilonewtons, it's equal to 1. You need to find out from this table. So single axle, single tires, for this thick, the width, tire width, you can consider 53. So to find the damage created by 40. So 53 is creating a damage of 1. So 40 is creating a damage of 40 divided by 53. 50 is creating a damage of 50 divided by 53. So 60 creating a damage of 60 divided by 63. Does that make sense? Yes. If they have given you, specifically tell you this, the width, you need to select that. Otherwise, you go with the top one, yes. Then it will be wrong. If they have mentioned you only, you can go with this other two. Normal one is this one. These tables are from Osroad. They are available. They are just copying and pay. No one will swap it. Yes, you get this one as it is. Next one, TAST. Tell me the damage. One damage is created by how many kilonewtons? What's that? 90. So you need to divide 40 by 90, 50 by 90, 60 by 90. How about TADT? What's that? 135. So 40 divided by 135, 50 divided by 135, and 60 divided by 135. 40 divided by 181, 50 divided by 181, and 60 divided by 181. Any question? Yes. 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 So you always go with this less than 375 if they haven't mentioned you. If they have specifically tell you that the tire width as given to you, then you go for the higher tire width. Otherwise, you just select the first one, which is the normal one. Okay. Any other? What's that? I can't hear you. Okay, so here this table is for ESA. So when you have to find ESA over heavy vehicle axle groups, you keep this table like this. But if in case there are other units as well, if you want to find SAR 5 over HVAG, what you need to do is SAR 5 means what? Standard axle repetitions 5. So we need to take it to exponent of 5. So if I do this to 5, that is for this one. Make sense? Any question? If I want to do it for SAR 7, the exponent will be 7. So if you want to make it to SAR 7 of HVAG, you do it for 7. If you want to do it for 12, your exponent will be 12. So you can find these ratios for even ESA, SAR 5, SAR 7, and SAR 12, anyone. Am I right? Any question? Any question? So I'm going to do for SAR 7 because I have done that, but you guys are doing for ESA. So have you done all these calculations in this table by yourself? Because my numbers will be different now because I'm going to do for 7. We are following the same procedure, but your numbers will be different than my numbers. Have you done this part calculation? No? Can you find this for few values at least? For you are doing for ESA, so you don't need to do for exponent. At least few of them. Because I have for SAR 7, not for the ESA. Okay, so I'm proceeding. I hope you know how to do, right? Okay, so I have these numbers, but not for the ESA. I have those for SAR 7. So I have this 7 exponent. Why? Because I'm doing for SAR 7. You guys don't have to do for 7. You are doing for just 1. Like you don't have an exponent. Now, when I find all these values, when I put those values in the calculator, I get this. This is my first table. Do you remember this table? The proportions. And this is my second table. This is the damage, and this is the proportion of the load and the groups. Any question up to here? Now, this much of damage is created by 1, but we have, or maybe 100. We have this much of proportion of SAST 40. So how do we find the damage created by this proportion? Do you get what I mean? If you consider one standard axle, one single axle, single tire, 40 kilonewton, one axle, it creates this much of damage. But do we have a one axle? No, we have 0.0385 number of axles, isn't it? So to find the damage created by this many number of axles, it's a proportion. That's why it is a decimal. So it will be, you need to times these two. Am I right? Is that right? Similarly, if I ask you to find the damage created by this one, you times these two, the corresponding cell. Am I right? So you need to do, for this one, it will be 0.0737 times 0.0010. So likewise, now you can multiply the right cells together and you have to create another table. Is it clear or not? So when I do that, I get this. How did I get this table? Just by multiplying the corresponding cells. So these will come to here. Does that make sense? If you consider this and this, that will be here. Make sense? Any question? These numbers are different to your numbers because this table is different to your table. Why? You need to do for ESA and I have done for SAR 7. What was the difference? I have one more additional step I have taken to the power of 7. But you guys don't have to take, but you need to know it. We don't know what you get in the exam. Okay, so when you add all these numbers together, that will give you SAR 7 over heavy vehicle axle group, this ratio. In your case, when you add all the numbers in the table, that will give you ESA over heavy vehicle axle. Yes, everything together. You add everything together. So in my case, I got 0.461. So I am again telling you this. These ones are not the same for every project. Depending on your traffic distribution, these ratios will be different. So we should know how to find them. Okay, so any question? No questions?